In this video, we're going to be talking about what it means to be a solution to a system of equations. So the solution to a system of equations is the ordered pair, which is an x comma y, that satisfies all equations in a system. So in other words, it's saying that it has to be a solution to each individual equation, and then therefore it'd be a solution to all of it. So we know we check solutions by substituting in values, and we're looking for true statements. When I get something like 5 equals 5, I know that whatever I had substituted in to get this is a solution to that equation. So let's look at an example. In this example, they want to know if 711 is a solution to this system. So we need to check to see whether it's a solution to each individual equation. The way that we do that is we are going to substitute in 7 for x and 11 for y in each equation. So in our first equation, I'm going to replace y with 11. We replace x with 7. And then we're going to simplify to see if we get a true statement. So we get 14 minus 3. Well, 11 does equal 11. So this tells me that so far, 711 is a solution to my first equation. But for it to be a solution to the system, it has to work for both of these equations. So now we're going to test it in our second equation in the system. So instead of y, we're going to substitute in 11. Instead of x, we'll substitute 7 plus 4. Well, 11 does equal 11 again. So again, because they're asking is it a solution, we have to say yes or no. So because it works for both equations, we get to say yes, 711 is a solution to the system. So not only does it work for each of them individually, each equation, but it's a solution to the system as a whole because it works for both. So let's take a look at a second example. In the second example, they want to know whether 2, 5 is a solution to this system. Again, we have to test each individual one. So starting with the first equation, I'll substitute a 5 for y, a 2 for x, and I'm going to simplify. So we get 5 equals 4 plus 1. Well, 5 does equal 5. So far, 2, 5 I know is a solution to my first equation. But to see whether it's a solution to the system, I have to check both. So we take our second equation, we do the same thing. Instead of y, we substitute a 5 plus 3 times, instead of x, we substitute a 2. And we see if this works. So we get 5 plus 6 equals 6, which right away, I know that's not true. So because I get a false statement right here, that means that 2, 5 was a solution to the first equation, but it was not to the second. So since I'm talking about a system as a whole, we have to say no, 2, 5 is not a solution because it doesn't work for both. Remember, the definition says it has to satisfy all equations in a system. And that's how we can check to see whether or not an ordered pair is a solution to a system.